Hello everyone, welcome to ODIA. And in this video lecture, we will discuss Pauline's law and solve some important questions that asking in IITian and get interest frequently. I will not only solve the questions but also explain you the method here. Pauline's rule. In 1929, Linus Pauling summarized 5 general rules that apply to ionic structure. The rule, now called Pauling's rule, he provided a convenient framework for examining the details of ionic structure. Now, Pauling's first rule. Pauling's first rule, sometimes called radius ratio principle. This law states that the distance between cation and anion can be calculated from their effective ionic radii, and cation coordination depend on relative radius of cation and surrounding anion. यहाँ पे हमको बोला गया है according to Pauling's first rule, we can also determine the coordination number from the radius ratio. Similarly, this rule says that very small cation will bond to only a few anions, while a very large cation may bond to many anions. यानी यहाँ पे आप देख सकते हैं वेरी अगर cation का साइज बहुत छोटा है then it only bond with very few number of anion. अगर हम अपना cation का साइज को इंक्रीज करेंगे then it may increase the anion numbers. Similarly, in other words, as the radius of cation increases, the coordination number also increases. Coordination number represent the number of anions are connected with a cation. Similarly, in figure 10, this is figure 10a, shows the limiting case when a cation just fit into the opening between 4 touching anions. अगर आप यहाँ पे अच्छे से देखेंगे, this is the cation and this is the anion here. In this case, this cation is connecting 4 anions here. You have to remember this formula and this triangle also. यहाँ पे आप देख सकते हैं, this is the right angle triangle. यहाँ पे जो हाइपोटेनियस है, हाइपोटेनियस का वैल्यू दिया है 2 इंटू आर सी प्लस आर ए, एंड यहाँ पे जो हाइट है इसका दिया है 2 इंटू आर सी. सिमिलरली इसका जो बेस है यहाँ पे दिया है 2 इंटू आर सी. ये आपको याद रखता है, यहाँ से कभी भी क्वेश्चन आ सकता है इन फ्यूचर. इफ एडिशनल आयन आर डायरेक्टली अबव एंड बिलो द cation द परफेक्ट ऑक्टाहेड्रल कोऑर्डिनेशन रिच फॉर्म. आप यहाँ पे देख सकते हैं एक cation के रेस्पेक्ट में 1 2 3 4 नंबर्स ऑफ आयन्स प्रेजेंट है. अगर हम ये cation के ऊपर एक और नीचे एक और 2 आयन पुट करेंगे then that form में octahedral. Now application to the Pythagoras theorem of right angle triangle in figure 10a. This is the figure 10a. Reveals the ratio of cation radius to anion radius to be 0.414. ये वैल्यू आपको याद रखना है फॉर दिस फिगर. ये क्वेश्चन डायरेक्ट आ सकता है. नाउ द फिगर 10b shows that we can use geometry to calculate radius of cation divided by radius of anion. For cation in perfect triangular coordination, that is RC by RA is 0.155. ये वैल्यू आपको भी डायरेक्ट कभी भी आ सकता है, ये आपको याद रखना है. नाउ वी कैन मेक सिमिलर through more complicated calculation for cation in tetrahedral, that is 4th coordination, that is 8-fold to 8-fold, dodecahedron, that is 12-fold coordination number also. Now this is an example, as an example of application Pauling's first rule. This is the application of Pauling's first rule. Let's take a halide. Halide represent NaCl, that is sodium chloride, and the radius of Na plus and radius of Cl minus are 1.10 Armstrong, which is the radius of sodium Na plus, and 1.72 Armstrong, which is the radius of Cl minus. The radius ratio Rc by Ra is answer is 0.64. Now we have to calculate this value represent which coordination number. Thus we can expect the cation Na plus to be octahedral coordination number. ये octahedral coordination number आपको जानने के लिए आपको ये टेबल याद रखना पड़ेगा. यहाँ पे रेडियस ऑफ कैटायन डिवाइडेड बाय रेडियस ऑफ एनायन का वैल्यू दिया गया है एंड एक्सपेक्टेड कोऑर्डिनेशन ऑफ कैटायन दिया गया है. यहाँ पे जैसे कि आप देख सकते हैं यहाँ पे हमारा आंसर आया है रेडियस ऑफ कैटायन डिवाइडेड बाय रेडियस ऑफ एनायन that is 0.64. The 0.64 value lies here, that is 6-fold coordination number. So the answer simply that is 6-fold coordination number. Now this is a question. In a mineral with chemical formula T4O8, the ionic radii of A and O are 1.12 Armstrong, which is the ionic radii of A, and 1.40 Armstrong, which is the ionic radii of O, respectively. The coordination number of cation, this is the cation which is A. यहाँ पे cation A का coordination number पूछा गया है. We can simply get from the given data here that the radius ratio principle, according to radius ratio principle, the radius of cation divided by radius of anion, हम simply यहाँ पे value put कर सकते हैं, that is 1.12 Armstrong and 1.40 Armstrong, and get the value of 0.8. From this value 0.8, we can, this is the value 0.8 present in 8-fold coordination number. So the answer simply the coordination number of A is 8. Now next question is the minimum anion to cation ratio of which a 3-fold coordination number become possible. यहाँ पे बोला गया है 3-fold रेडियस रेशियो बोला गया है. 3-fold में जो सिस्टम में जो हो रहा है उनका रेडियस रेशियो है 0.155 से 0.225. सिमिलरली यहाँ पे जो डाटा गिवन है दैट इज रेडियस रेशियो. रेडियस रेशियो में हमको पता है रेडियस ऑफ कैटायन डिवाइडेड बाय रेडियस ऑफ एनायन, पर यहाँ पे हमको जो पूछा गया है द क्वेश्चन इज एनायन टू कैटायन रेशियो एंड मिनिमम पूछा गया है. सो सिंपली हम इसको जो इसका रेसिप्रोकल ले लेंगे दैट इज रेडियस ऑफ एनायन डिवाइडेड बाय रेडियस ऑफ कैटायन. सिंपली हम आंसर निकाल सकते हैं 6.45 से 4.45 एंड दिस इज द मैक्सिमम एनायन. जो 5 पाउलिंग्स रूल है यहाँ से आपको डायरेक्टली एमसीक्यू और एमएसक्यू क्वेश्चन पूछ सकते हैं. इसके अलावा पाउलिंग्स रूल के जो एप्लीकेशन है यहाँ से आपको न्यूमेरिकल्स भी आता है एग्जाम्स में, तो यू हैव टू टेक इट सीरियस. नाउ पाउलिंग सेकेंड रूल, sometimes it called electrostatic valency principle. This law states that we can calculate the strength of bond by dividing ion valency by the coordination number. यहाँ पे सिंपली बोला गया है to determine the strength of a bond we have to simply divide valency divided by coordination number. This is an example here. In halide, which is NaCl that have 6 anions bond there to each Na plus, and Na plus that is the cation which is surrounded by 6 anions. In this case the strength हम determine कर सकते हैं, that is the formula is here, that is the valency. Valency is 1, that is Na plus plus 1 है तो valency is 1, and the coordination number यानी cation के respect में कितना तो anions present है, that is 6. So the strength is 1/6. Now moving toward another question. In the Uvarovite garnet, Ca3 plus 2, Cr2 plus 3, Si3 plus 4, O12, Ca. Ca is in the cubic coordination system. Now chromium is in octahedral coordination and Si is in tetrahedral coordination. The electrostatic bond strength of Ca plus 2 central iron is dash. यहाँ पे आपको क्वेश्चन पूछा गया है 2 डेसिमल में. यहाँ पे सिंपली यू कैन गेट दैट Ca plus 2 का चार्ज plus 2 है. इट क्रिस्टलाइज इन क्यूबिक कोऑर्डिनेशन नंबर दैट इज 8-fold कोऑर्डिनेशन नंबर. यहाँ पे बॉन्ड स्ट्रेंथ आप सिंपली निकाल सकते हैं द वैलेंसी divided by coordination number, that is 2 divided by the answer is 0.25 which is in 2 decimal. Now moving towards Pauling's third rule. Pauling's third rule is that coordinating polyhedral become less stable when they share edges and they are extremely unstable when they share faces. आप यहाँ पे फिगर में देख सकते हैं when the polyhedrals share face that is mostly unstable with compared to the other. When it share edge that is more stable than face sharing. Similarly, when the polyhedral share cortex, it is more stable than edge sharing and face sharing. Similarly, in isolated tetrahedra, this is the most stable one. Now, moving toward fourth rule of Pauling. Pauling's fourth rule is extension of his third rule. This states that small cation with high charge do not share anion easily to other cation. This is another consequence of this fact that highly charged cations will repel each other. From example, all silicate mineral contain Si4 plus and that is tetrahedra. Now moving toward Pauling's fifth rule, we call Pauling's last rule, which is principle of parsimony. It says that atomic structure tends to be composed of only few distinct components. That means the atomic structure tends to simple and order. यहाँ पे ये fifth rule states that कि this is the simple and orderly arrangement of their polyhedron. They normally have few type of bonds and only few types of cation and anion site, while a mix of anions on a particular site is possible. The mix of limiting and calculated. यहाँ पे आप देख सकते हैं according to law of parsimony, all are calculated and limited. They are perfectly and orderly stable. If you want the notes, then join our Telegram group ODIA. Link is given below. Thank you for watching this video lecture. If this lecture is informative to you, please like, share and subscribe. Thank you.